Maps quietly teach us what to fear, admire, and ignore. They frame big and small, near and far, and we absorb those lessons as if they were physics. Today's idea is simple and slippery. The way we draw the world reshapes what we believe about it. Projections, orientations, and boundaries aren't neutral. They carry choices, which meant they steer our sense of size, distance, and importance. Start with the projection that shaped classrooms and cockpits for centuries, Mercator. A projection is a rule for flattening a round Earth onto a flat page, which always trades one virtue for another. Mercator, published in 1569, keeps local angles and compass bearings true. If you sail a constant heading, that path draws as a straight line, which meant early navigators loved it, but preserving angle distorts area, and the distortion grows toward the poles. Greenland swells like a giant, and Africa shrinks, even though Africa is about 14 times larger. You can hear the stretching if you describe it out loud. Near the top and bottom of a Mercator map, the grid lines spread apart, which means each square of ink represents more Earth than squares near the equator. Antarctica becomes a long white shelf across the bottom edge. Canada and Russia inflate, while Brazil and Indonesia look modest, therefore size signals get scrambled. Equal area projections make a different promise. They keep relative areas correct, which meant continents keep honest proportions at the cost of bent shapes. On an equal area map, Africa regains its heft and the tropics look vast, but coastlines wobble and angles warp. No projection gives you everything. You pick what to save and what to sacrifice. This choice matters whenever bigness is part of an argument. If someone points at a stretched country to argue power or vulnerability, ask which projection you're looking at, because the ink might be doing half the talking. Now to a quieter myth we barely notice. North is naturally up. It feels intuitive because compasses point north, and many school maps put the Arctic at the top. But up on paper is a convention, not a law. Medieval European-oriented maps sometimes placed east at the top, which is where we get the word orientation. Several Islamic maps from around the 12th century put south at the top to mirror astronomical diagrams. Classical Chinese cartography often favored south up because emperors faced south in court, therefore south aligned with authority. Why did north up win the modern wall? As European navigation standardized and the prime meridian through Greenwich spread after the 1884 conference, mapmakers aligned north with the top for consistency, which meant textbooks and globes locked the habit in place. Flip a world map south up and watch your attention migrate. Suddenly, Patagonia, New Zealand, and Antarctica dominate the upper field, and Europe sits low, which quietly challenges the hierarchy you took for granted. Nothing in physics prefers one orientation. Gravity doesn't pull maps, culture does, and that means you can choose a view that serves the question instead of the habit. Next, let's cross an invisible seam with very real consequences. The International Dateline. A dateline is the boundary where the calendar flips by one day when you cross, because the planet needs a place to stitch together time zones. The line roughly follows the 180th meridian through the Pacific, but it zigzags like a careful driver avoiding puddles. It detours around Siberia and Alaska to keep neighbors in sync, then bends around island nations so their far-flung atolls share the same calendar as their capitals. Kiribati shifted its timekeeping in the 1990s, so all of its islands could wake to the same date, which meant the line had to bulge far east. In 2011, Samoa hopped from the American side to the Australian side for trade reasons, therefore it skipped a Friday entirely. Here's a traveler anchor you can test. Fly west from Los Angeles to Tokyo on a Friday night, cross the line, and you land on a Sunday morning, which feels like you lost a day, even though the flight took about 11 hours in the air. Fly back east on a Wednesday and arrive earlier on the same Wednesday. You did not time travel. You re-entered the old calendar because clocks wrap around a globe that refuses to be flat. This zigzag isn't chaos, it's compromise. Countries pick what keeps families, markets, and elections aligned, which means the line bends to human needs more than abstract geometry. Finally, let's tackle distance itself, because flat maps also warp our path-making instincts. The shortest path on a sphere is a great circle, which is any route that lies on a circle sharing Earth's center. On a globe, a great circle looks like a straight belt. On most flat maps, that belt becomes a curve that bows toward the poles, which startles anyone who trusted a ruler more than a globe. Compare two kinds of routes. A loxodrome keeps a constant compass bearing and draws straight on a Mercator map, which meant sailors could steer one heading and update for winds. A great circle changes bearing as you go but shaves distance, therefore long-haul flights bend north or south even when your destination sits roughly east. Los Angeles to Tokyo often arcs near Alaska because that curve is the true short way across a round Earth. This isn't cartographic trickery. It's geometry with altitude. The Earth's circumference is about 40,000 kilometers, and shaving even a few percent matters for fuel, time, and weather windows. Your eyes still fight the idea. They like straight edges on paper, which meant for many of us a E-curved route feels longer even as math says it S shorter. Pilots and routing software reconcile the two views. They compute great circle waypoints, then adjust for winds aloft, jet streams, and restricted airspace because reality layers physics, politics, and weather. All of these moments, Mercator stretching, north-up habit, dateline bends, and great circle arcs, share one truth. Maps are stories told with math, and every story highlights something while dimming something else. So here's your decision challenge, and we'll keep it crisp. You must plan the shortest flight from Los Angeles to Tokyo using a flat map. You can only choose one instruction for the navigation clerk. Pick draw a straight line across the page, or draw a curved route that bows toward the north. Post your choice with a one-sentence defense that names the principle: angle preservation, area honesty, the dateline, or great circles, because the why matters more than the line. We'll reveal it and highlight the best takes in the next MindMaze stream. Before we go, hold this takeaway. Whenever a map feels authoritative, ask which feature it preserves, which meant you won't confuse convenience with truth. If this episode stretched how you see size, direction, time, and distance, subscribe for more mind-stretching journeys each week.